Okay, so let's look at the first one. Lisa wrote the expression below, 9 times 7 times 2. What expression is equivalent to her expression? So I want to look for whatever is equivalent, meaning it's going to have the same value as all this. So usually when that happens, what I do is I try solving out the problem. And I know that I'm going to multiply what's in here first and then get my answer. But when I looked at the choices, I see that they're not asking me for the actual answer. You just want to know what's equivalent. So I look to see which one will give me the same answer. Since I'm just multiplying all three of them, it doesn't matter if I'm doing 9 times 7 first or 9 times 2. So I know that this is the correct answer. For the next one, I'm going to try and cover up the choices just so that I'm not really looking at it. Okay. Yina has 2.3 meters of string, and she gave 1.6 meters of string to a friend for an art project. How much does she have left? That means I'm going to subtract. So she had this, and she gave away this. As soon as I set it up, I see a problem. I need to put a placeholder, and now I can subtract. I try telling the kids to just look for this part first and ask yourself, do I have enough to subtract? 2 times 1, I can do. I can't do 3 minus 6, so let me just borrow now. 13. And I can't do 0 minus 2, so let me just borrow now. 12, 10. This makes my subtracting easier. 10 minus 2 is 8. 12 minus 6 is 6. 1 minus 1 is 0. Now I just have to look. Bam, there's my answer A. I never look at the answer choices. I always just cover them up first. Okay, in this 5th grade class, so I'm going to underline 5th grade class, there are 94 prize boxes at the fair. He has a package of 600 toys. So he has 600 toys, and each prize bag has 6 toys. So he has 94 bags, prize bags, and each one has 6 toys. So I'm going to multiply this first. 54 plus 2, 56. And I want to know how many toys will he have left after the bags. So he had 600 toys, and because they're telling me that, and we're already using 564. So I'm going to do my trading again. I can do this, but I can't subtract here, so I'm going to borrow. And I can't subtract here, so I'm going to borrow again. Now I can subtract. 10 minus 4 is 6. 9 minus 6 is 3. 5 minus 5 is 0. My answer is 36. I look. There's 36. I don't get tricked when I cover up my choices this way. Look at number 4. Okay. I'm going to cover again, so I don't want to look. Casey drew a decimal picture. In Casey's picture, each small square represents 100. So just by looking at it, I can see this is 1, and this is 1, and here she has 28 hundredths. So her picture is showing me 2 and 28 hundredths. After drawing the picture, she adds 1 and 35 hundredths to the picture. What is the total amount shown? So I'm doing what is 228 plus 1 and 35 hundredths. So when I add them up, I get 3 and 63 hundredths. They really just want to see that you knew how to figure out this picture. And there's my answer, D. Next problem. Which number is 3 times larger than the value z? So I'm looking here and I see that z has to be a fraction because it's less than 1. So this is halfway. That's a half. And what's half of a half? I know that half of a half is 1/4. Why? Because when I think of the number, when I think of 1 whole, when I cut it in half, I have halves. And when I cut them in half again, I have 4 pieces, so this will be a 4th. Okay? So what is 3 times larger? That means I'm going to multiply this by 3. To do that, I'm going to turn this into an improper fraction, put a 1 under it. And now I'm just going to multiply across. 1 times 3 is 3. 4 times 1 is 4. I get 1/4, and 3/4, and here is my answer. keep going down. So far, we're already up to number 6. Woodland High School has 253 students participating in a bake sale. Each participant bought 25 baked goods. How many baked goods were included in the sale? So everybody bought baked goods. So 253 times 25, because each person bought 25. So I'm just going to multiply that out. Put a 0 as my placeholder. 2 times 3 is 6. 10. Carry the 1. 5. I know I'm multiplying fast. 5, 2, 3, 6. So 6,325. 6,325. Only one more page to go. Hover up. A small toy weighs 9 thousandths of a kilogram. Which number below represents 9 thousandths? So I'm going to make my little chart. Here's my decimal. I have tenths, hundredths, thousandths. Because this is my chart, it tells me how big a number goes. So I want 9 thousandths. So I want 9 of these. Nothing else. So my answer should be 0.009. Let's look. 0.009. Easy. This one's a little tougher. Dino is cutting 7-inch strip of cloth into 1/4 inch long pieces to make labels for the clothes he will wear to camp. Dino uses the equation to figure out how many labels he can make. There's his equation, 7 divided by 1/4. Which equation can Dino use to check his calculation? To check. So we want to go backwards. Those are kind of like those problems where you would do like 3 times 8, 18 equals, and you try and figure it out. In this case, you would get 54. So what's the way I would check? I would just do 54, and I do the opposite. I divide it by 3 to get 18. So we want to do the opposite. Instead of 7 divided by something equals this, what times 1/4 is going to give me? 7. That's what I'm looking for. And what situation is that? Right here, because I want the opposite. 2 more to go. Time problem. Kids always have issues with time. Keisha went to a play that was 2 hours and 25 minutes long. If the play started at 2:40, what time does it end? So it starts at 2:40, and I'm going to add time because this is the start. I want to let's add 2 hours first. So I'm only going to add that to the hours time, and that's just 4:40. And now, because I want to add 25 minutes, first I know if I add 20 minutes, that's 5 o'clock. And now I can just add the last 5 minutes. And that's 5:05. So I have to know a lot about time. I have to know that every time I get 60 minutes, it's another hour. This is where kids get really tripped up. Because if I just put 25, some kids would write 4:65. And that's not a real time. So you would have to know what time that really is. And let's look here. And you get 5:05. Last problem, order of operations. So let's just cover up these choices real fast. And look through. And that means I'm going to write down automatically P, E, M, D from left to right, A, S from left to right. These are my steps. And I'm going to rewrite the problem just so you can see it. 4 times 9 plus 12 divided by 4 plus 2. So I'm going to do my parentheses first because that's first there. That's 6. I'm going to write everything else down. Now I'm going to multiply from left to right, so I'm going to do this part first. This is 36 plus 12 divided by 6. Now I'm going to divide next. This is 2. 36 plus 2 gives me 38. And there is 38. Notice each time I always figured out the problem before just choosing one.